Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Darina Aisyah binti Kamaluddin. Today I would like to present about introduction of high performance liquid chromatography HPLC. What is HPLC? HPLC is a method used to separate, identify and measure chemical in a mixture, include non-volatile and thermally unstable compound. How HPLC work? First, analyte will dissolve in a solvent and then force through the column under high pressure. HPLC utilizes a liquid mobile phase to separate the component of a mixture. HPLC is very versatile. Why? Because of its ability to easily separate a wide variety of chemical mixture. HPLC also accurate and reliable in separation caffeine from other compounds in tea, cafe and related products. Next, caffeine in products. Caffeine is found in tea, cafe, cocoa and energy drinks, making it important to measure for quality and safety. HPLC provides significant advantages in caffeine analysis due to its ability to separate caffeine from other interfering compounds. Ensuring precise quantification, the method involves the use of a liquid mobile phase to carry the analyte through a column packed with a stationary phase, where the compounds are separated based on their chemical interaction with the stationary and mobile phases. The caffeine content can then be detected using UV-Vis spectrophotometry, typically at wavelength around 272 nanometer, where caffeine shows strong absorbance. Here are three key advantages of HPLC. First one, fast and precise. Second, works well with small sample amount. And the last one, advantages useful for routine testing in industry. Factors such as the type of chromatography column, mobile phase composition, and flow rate are optimized to achieve high resolution and repeat analysis. In caffeine analysis, reverse phase HPLC is commonly used, as it provides efficient separation of caffeine from related alkaloids and other metric components. The technique is robust, capable of handling a wide range of samples, including tea leaf, cafe beans, instant beverages, and energy drinks. And the last part for introduction HPLC, purpose of analysis. Purpose of caffeine analysis is to ensure products meet quality standards and legal limit for caffeine content. For this experiment, which is high performance liquid chromatography, we have three objectives to achieve. Firstly, to determine the retention time of standard solution, which is caffeine. Second, to identify the caffeine peak in a soft drink sample. And the last one objective is to determine the amount of caffeine in soft drink sample using the response factor method.
Hi, my name is Jeffrey Nasira. For this part, I would like to explain about what is principle used in HPLC. There is four principles used in HPLC. Firstly is sequence by injecting the solid analytes onto the top of the column. Secondly is separation occurs as the analytes and mobile phase are pumped to the column. Thirdly is each component edits from the column as fit on the recorder. And the last one is the response of detector to each component is displayed and known as a chromatogram. Next, I would like to explain about the HPLC instrumentation. There have 6 processes in HPLC instrumentation. Firstly is mobile phase reservoir and solvent treatment. Reservoir is the function of to store the mobile phase, typically in glass bottle. The gases are functioning to remove dissolved gases to prevent flow rate issue and detector interference, commonly used in method to spudging with helium or using ultrasonic sonication. Manual filter is to eliminate dust and particulate to avoid damage to pumps, injector and column. Secondly is pump. Pump function to process the mobile phase through the system under high pressure. There have 3 types of pump. Firstly is reciprocating, displacement, and pneumatic pumps to ensure stable pulsation free flow for consistent performance. Thirdly is injector. Injector are used to introduce the sample into the mobile phase. There have 2 types of method in manual injection. Firstly is shrink with a self-sealing system, and secondly is automatic sampler, which is enable high throughput injection for multiple samples. Fourth is column. Column function to separate the sample component based on their interaction with the stationary phase. There have 2 types of column. Firstly is analytical column, and thirdly is guard column. And the fifth is detector. Detector are used to detect and measure the separated component as they elute from the column. They have two types, which is bulk property detector, are to measure changes in mobile phase refractive index or density. Meanwhile, solid property detector are used to measure specific properties like UV absorbance or fluorescence. And lastly is data system. Data system will record and interpret the signal from the detector, and the output will generate chromatograms to analyze the composition of the sample.
For method in part B, we need to prepare two things. The first one is we need to prepare the caffeine standard solution, and the second one we need to prepare the sample for analysis, which is we use coke and beta. For preparation of caffeine solution, there are two steps. The first one is we need to make stock solution. To make stock solution, we need to weigh 10 mg caffeine and transfer it into 10 ml volumetric flux and dissolve it with the distilled water. After we finish make a stock solution, or we call it as solution A, we go to the second step, which is to make stock solution B. For solution B, we need to pipette 1 ml of solution A and transfer it into a 10 ml volumetric flux, then dilute it with distilled water until it reach calibrated line. For the next step, we need to prepare the sample for the analysis. The first one, we need to pour 10 ml of coke and 10 ml of the beta into the small beaker. Then we need to stir it using the magnetic stir to remove the carbonation. Then we need to filter it using membrane filter. The last process is to detecting the peak in HPLC. The first one we need to do is inject 10 microliter of solution B into HPLC to get retention time of caffeine. Then we can measure the peak. So do the same for the coke and Levita, which is inject 10 microliter of coke and Levita into HPLC. Then we can measure the peak area.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Haikal Birasli. My student ID is 2022605638. So I'm going to show the result of the study. The first one is Figure 1 show the graph of determination of the caffeine in the standard caffeine. Next is Figure 2 show the graph for determination of caffeine in coke. And the last one is Figure 3 show the graph for the determination of caffeine in the standard Levita. The next one is this is the tabulated result of high performance liquid chromatography (HPLC). Analysis yielded a valuable insight into the retention time and peak area of the caffeine in all samples successfully fulfilling the experiment objective. The caffeine standard exhibited the retention time of 2.482 minutes and peak area of 6,249.48779. This result will be used as a reference for identifying the caffeine in other sample. The coke sample display a retention time of 2.481 minutes, almost identical to the standard. This confirmed the presence of caffeine in the soft drink. Its peak area was 7,001.12305, indicating a higher concentration of caffeine compared to the standard for Levita. It showed a retention time of 2.479 minutes, also near identical to the caffeine standard, with a noticeable higher peak area of 11.1151.10, suggesting that Levita contained a significant more caffeine than both standard caffeine and coke sample 4.
Hi, my name is Sophia. In this lab, I will explain about discussion. The study successfully developed and validate an HPLC UV method for caffeine. Example, caffeine in standard caffeine, caffeine in coke, and caffeine in Levita. The result indicate that Levita has the highest concentration using the response factor method. The relative caffeine content in the sample was quantified by comparing their peak areas to that of the standard. This method revealed that Levita contained the highest caffeine content, followed by coke based on the caffeine standard solution. This finding not only confirmed the presence of caffeine in tested sample but also provide a quantitative measure of their caffeine concentration, thereby fulfilling the objective of the experiment. Furthermore, the result validate that the HPLC method effectively and accurately separate caffeine from other components in the soft drink. The retention time of caffeine for all samples was nearly identical, with minor variation likely due to slightly difference in the column packing or the mobile phase composition of the HPLC system.
So for the last part is conclusion part. In conclusion, we are successfully determined the retention time of the solution's caffeine is 2.482 minutes. The second one, we also successfully identify the caffeine peak area in cope and also Levita sample.